Everybody, this is a walkthrough about the 1500 watt heater problem plugged into a 120 volt outlet. In this problem, we're given the power rating of the heater and we're given the potential difference that it's going to be plugged into. Those two together can help us find the current because P equals I delta V. It might not be so obvious that this equation makes sense at first, but what's happening is that power is measured in watts, current is measured in amps, and the potential difference is measured in volts. A watt is a joule per second, and that's equivalent to an amp times a volt. An amp is a coulomb per second, and a volt is a joule per coulomb, and those all cancel out, and you can see that this side of the equation is measured in joules per second, or watts. Working through this equation easily gives us what the current value is. Part B asks for the resistance, and there's a few ways you can get there. By saying P equals I times delta V, neither of those has R in it, but we can put R into there using Ohm's law by saying that delta V either equals I times R or I equals delta V over R, both of which are just things we know from Ohm's law. Those equations become, if I simplify them, I squared R or delta V squared over R, which are all equal to power. Power is still the rate of change of energy, how much energy you're getting per second given off by a resistor. That's electrical potential energy turned into heat, how fast it can do that. And then I delta V is a different way to say power, or you can say I squared R, or you can say delta V squared over R. All those work. To figure out how much heat we're getting, or to relate that to time, like in part C, we can say that the amount of time is equal to the change in energy divided by the power. That change in energy is this, mc delta T, which you may have seen in chemistry and you may have not have, but it's a way to talk about heat that's transferring to an object. That is an amount of heat. It has to do with the mass of an object, the specific heat, how much energy it takes to increase a kilogram of that object 1 degree Celsius, and then the change in temperature, how many degrees Celsius you want to go up. In the problem given on Mastering Physics, you are trying to change the temperature of a living room, which it gives you the volume of the living room, or at least the dimensions. You can multiply those dimensions all together to get the volume. And then it gives you the density, which I've called this symbol rho right here, density. That can give you the mass of the air in the living room. Then, if you know this relationship, and we know that it's 1500 watts of power, you can solve that to get the time that it would take to heat up that living room. All right, email me with any questions that you have, or respond to the post where I posted this.